Today is a pretty short day. We're going to talk about a calculation called a determinant of a matrix. And you can really only do determinants for square matrices. In other words, the number of rows equals the number of columns. We're going to talk today about a 2 by 2 and a 3 by 3. We can extend that all the way up. The thing about our calculators is they'll calculate this really quick, and you won't know why you're doing it, how you're doing it. The reason why right now is just to learn a process that you might need to use if you move into higher order math in college. And it's good to know what a determinant is and how to go about calculating it so that when we get into more intricate details of these determinants, you'll know where you started from in the base. So in other words, a second order determinant is basically the calculation of a determinant of a 2 by 2 matrix. In order to get that calculation, DET stands for determinant, we take the diagonal products and their difference. So we multiply AD by BC and then take their difference. The determinant of this matrix is notated by what looks like an absolute value sign, and there's my product of AD times BC, and I take the difference of that. So in a specific example where I have a 2 by 2 with numbers actually plugged in, I multiply this diagonal to the left, the first diagonal, which is 4 times 6, multiply the second diagonal 5 times negative 3, and then take the difference between the two, thus yielding 39. So here's a case in which I have a 3 by 3 matrix and I'm asked to find the determinant of that 3 by 3. Now notice what I've done. I've copied the columns down next to the original matrix here. And now I've created 3 diagonals moving to the right and 3 diagonals moving to the left. Notice the plus signs on top and the subtraction signs on the top of these. I take the product of each of the terms in the positive facing diagonals and the product of each of the terms in the negative facing diagonals. Once I've done that, I add the products of the positive facing terms and subtract the products of the negative facing terms. Let's do a specific example. We'll start with our 2 by 2. Want to find the determinant, so I'm going to take and multiply the diagonal of negative 9 and 5, and then subtract off the multiplication of the diagonal of 6 and 1. So this gets me negative 45 and minus 6, which is negative 51. Pretty cake. Next, we'll do my 3 by 3. When I do this 3 by 3, I want to rewrite that diagonal. I take and say, all right, I'm going to write a 4 here, a 5 here, a 2 here. Write the second column over, a 2, a 1, a 0, and then a negative 1, a 1, and a 3. I'm going to, once again, put an arrow to the right, arrow to the right, arrow to the right, and then I'll go arrow to the left, arrow to the left, arrow to the left. Everything to the right gets a plus sign. Everything to the left gets a subtraction sign. And now I'm going to take the products. So here I have 4 times 1 times 3 in this first diagonal. In my second diagonal, notice the plus sign. I have 2 times 1 times 2. In my third diagonal, I have negative 1 times 5 times 0. Next, I'm going to subtract this backwards diagonal here. So that's 4 times 1 times 0. Subtract this diagonal, which is 2 times 5 times 3. And then subtract this diagonal, which is negative 1 times 1 times 2. Clean it up. There's a 12. There's a 4. That's 0. minus 0 minus 30. This is a negative 2 when I multiply together, but I'm subtracting a negative 2, which is adding a 2. So I have 16 minus 30 plus 2, which ends up being negative 12. Notice, calculations of determinants get me singular numbers. That's really all we're doing today. Again, it's a calculation. At this point, it's not doing much for us, but it's a building block to use in later math. Make sure you fill out your summary, do your Connect Ed problems, and we'll talk tomorrow.